Good morning, everybody. This is Mr. Lowe. Actually, good evening, I guess, if you're watching this tonight at home. This is our review for Unit 9. We're going to cover lots of different things, along with, I think, maybe one or two other items that I didn't cover in class. So let's go ahead and get started. Today we're looking at calculating area, and in this case it says write an expression that represents the area of this parallelogram. So for us, as we look at the area of the parallelogram, I have my parallelogram here. It's got a pair of parallel sides right here, and this one on top, and this one on the bottom. And I know that the area equals the length of the parallelogram times how high that parallelogram is. The length is the length of the base. So the length from here, this dot, all the way across the bottom to that dot. We're going to count line segments here, and there's 1, 2, 3, 4, 5. So my length is going to be 5 centimeters times how high. Now, how high is it? It's from the top of my parallelogram all the way down to the bottom, to the base of my parallelogram. So from the top, the highest point, straight down, perpendicular to the bottom. And right here, where it forms a 90-degree angle, is where my perpendicular line is. It would be perpendicular to this line right there if we continued the base that way. Right here is my 90 degrees, and it gives me 1, 2. So I have 5 centimeters long by 2 centimeters high. Right there is the answer that they're looking for. That is the equation or an expression that would tell you what the area of that shape is. Now we can obviously do the math. 5 times 2 is 10. And remember, whenever we're dealing with the area, we are dealing with centimeters squared, square units. It's got to be squared. Okay, any questions with the first one? Excellent, let's move on. And even if you did have questions, you can always pause and rewind. Question number 2 says, what should Billy measure to determine the amount of paper he needs to wrap a paper box in? So here's a paper box. I kind of color-coded it for you so you can kind of see what it would look like. I know in this box, or in this cube, I have a total of 6 faces. Now the faces of my cube, one of them is this red one here. That's the front face. The other one is the blue face. That's going to be the back. And then I have a face on this side that represents my right side. Over here that represents my left side. I have a face that is on top of my cube and a face that is on the bottom of my cube. And I know that when we're dealing with paper and I'm trying to wrap this box, I'm really trying to cover surface area. And when I'm dealing with surface area, I need to know how much paper is going to wrap that entire area. And I know that if this were, let's say this were 6 centimeters, this were 6 centimeters, and because it's a cube, this were 6 centimeters, we would know that each face would have an area of 36 centimeters. 36, that's a terrible 6. Centimeters squared, and I know that I have 6 total faces because we counted those, so I would just have to multiply that by 6 to get the entire surface area of all 6 faces of my cube. So 6 times 6 is 36, 6 times 3 is 18, plus 3 is 21. I have 216 square centimeters of surface area. Okay? Alright, so you really want to calculate surface area on this type of problem. You can also do surface area for a cube, you can do surface area for a cone, you can do surface area for a cylinder, all that other kind of stuff. We'll talk about that later on. Moving on. Paul's putting up a fence around all 4 sides of a rectangular flower bed. Here's the diagram for the flower bed. The flower bed is 12 feet wide, so that's 12 feet wide. Oh no, not 12 feet wide. Sorry. It is, 8 feet wide. There we go. 8 feet wide. Now you can read it. 8 feet wide by 12 feet long. So it's an 8 by 12. each section of the fence is 2 feet long. So my entire fence is 2 feet. So each section is going to be 2 feet. I need to figure out how many sections of fencing do I need. Okay, and I'm not sure where that one is. I must have missed that. Let's see if we can't fix that. There we go. Now we should be good. Nope. How many fixings of fencing? Aha, there it is. And I want to paint that white. Now we should be good. There it is. Alright, so how many sections of fencing do we need? So I have in my answer, if each section is 2 feet long and this first length is 8 feet, well, this means that this section here and each of these sections is going to be 2 feet long, which means for my 8th section it is 4 sections of fencing. 1, 2, 3, and 4. For my 12 section, that means I'm going to take 12 and divide it by 2. That'll tell me how many fences I need. That means for my 12-foot section from here to here, that means I am going to have 6 sections of fencing. So if I have 6 here, I'm going to have 6 over here. And if I have 4 here, I'll have 4 down here. Whoops, not 8, 4. Let's fix that here real quick. So on this side I have 10, on this side I have 10. That means I need a total of 20 sections of fencing. So each one's 2 feet long. I need a grand total of 20. Okay, moving on. At what point is 4, negative 4? Now, when you're dealing with coordinate planes, you have to understand a couple of different things. I have to realize that my x-axis is the one that goes across the page left to right. My y-axis is the one that goes up and down, and that the first point in my coordinates is always your x-coordinate, and the second point in your coordinate is always your y-coordinate. So when I'm graphing this, I need to make sure I go to 4, positive 4 first, which is right there, and then I need to go to negative 4, positive 4, and then negative 4. That leaves me with D as my point that is located at 4, negative 4. And just in case you're ever wondering, this is going to be in quadrant number 4. Remember, it was quadrant 1, quadrant 2, quadrant 3, quadrant 4. Let's continue. If a square's perimeter is 36 inches long, what is the area of that square? Well, in my head, I'm thinking, well, I know perimeter equals, I add all my sides together. So the easy formula is side plus side plus side. Or, that's an S. Or I could say it is 4 times the length of one side. So 4 times the length of one side equals 30. Whoa, that was kind of weird. Equals 36. That means if I divide both sides by 4, and I do 36 divided by 4, I should get the length of one side, which is 9. That means my square now is a 9 inch by 9 inch rectangle. And in my area equation, area equals length times width. I'm doing 9 inches times 9 inches, which equals 36 inches. Or no, not 36. Hello. How about 81? 81 inches squared. 81 inches squared is the area of a square if its perimeter is 36 inches. Okay, well done, you guys. Moving on. What is the area of the shape pictured at the right, or in this case, down below? And when we're given a shape that is odd or irregular, we want to be able to divide it up into rectangles. So I might draw a line here and say that's one shape, and draw a line right here and that's a different shape. Now all we got to do is figure out the dimensions. Well, this one is a square. It's a 2 by 2 square. So if this is 4, that's also 4. The area of this section is going to be 4 times 4, which would be 16 yards squared. The area of this section, this is 4, means this is 4. Now all I need to do is figure out how long this whole side is. Well, if the entire thing is 10 inches, and I know that from here to right there is 4 inches, I just need to figure out what that little piece is. And that is going to be 2 inches, which makes this entire thing 6 inches. Which means we are looking at a 4 by 6, which is 24 yards squared. And my last one is a 4 by 10, which is 40 yards squared. Now all I got to do is just add them all up. So I have, let's see, 16 square yards plus 24 square yards plus 40 square yards equals, I want to add all those up. 6 and 4 is 10, plus 0 is 10. 4 and 2 is 6, 7, 8. 80 yards squared is the answer of the area of that shape. Well done. Let's move on. Calculating the area of each figure. Again, what you want to do here is you want to make sure you understand, number one, that the area of a triangle is equal to 1/2 base times height. 1/2 the base times the height. My base is going to be the length of my triangle from here to here. Usually we try and get one that's the shorter, not necessarily the shorter side, but the more horizontal. The more horizontal, the better off it's going to be. So this would be 1, 2, 3, 4 times how high. Now the height of my triangle is usually the one that gives us the most issues, and the height of my triangle goes from the tip of my triangle straight down. The key word is straight down. It's got to be perpendicular to my base. Has to be straight down. That leaves me with 1, 2 as my height. And I'm going to multiply those two together and then times them by 1/2. So I have 1/2 times 4 times 2 is 8, and half of 8, that's a parenthesis, half of 8 equals 4. So the area of this triangle is 4 centimeters squared. Outstanding. The area of my parallelogram now is area equals, this will be number 2, area equals length times width. How long my parallelogram is from this point to this point, 1, 2, 3, 4, times how high my parallelogram is. And again, we want to make sure we're looking at from the top of my parallelogram perfectly straight down to where it would intersect the base, if the base continued. So it's got to form a 90-degree angle. You could also drop it from here to here, and you're still going to get the same answer. So I have 1, 2, 3, 4. 4 times 4 equals 16 centimeters squared. Any questions? Let's do a couple of more, and then we're going to be done here soon. Last two are a little bit more difficult. They're word problems. Said last year Miss Cozier has made a garden in her backyard with dimensions that were 8 by 12. So she had a garden, and that garden was an 8 by 12 foot garden. This year she wants to double the length and the width. We need to compare, I'm going to underline that, the perimeter and the area of both last year and this year. So I am going to split my paper in half. And we're going to do last year over here and this year over here. And let's get to work. So I have last year's area and perimeter. Area equals length times width, which means I'm doing 8 times 12. And 8 times 12, let's see, 8 times 2 is 16. Carry my 1. 8 times 1 is 8, plus 1 is 9, would be 96 feet squared is my perimeter. The area, or is my area, sorry. The perimeter is going to be 8 plus 8 plus 12 plus 12. So 8 plus 8 is 16. 12 plus 12 is 24. And when I add 16 and 24, 6 and 4 is 10. Carry my 1. 2 plus 1 is 3, plus 1 is 4, is going to be 40 feet. So I have a perimeter of 40 feet, an area of 96 feet. This year, she's going to double it. So this year's garden, apparently she's hungry, she wants to make more vegetables, is now a 16 by 24. So we've doubled the width, we've doubled the length. And let's continue and let's calculate our area. Equals length times width, which is 16 by 24. And let's do the math here. Whoa, that was kind of crazy. Sorry about that. 24, 16. 6 times 4 is 24. Which 2 up here. 6 times 2 is 12, plus 2 is 14. I'm going to run out of room. Add my 0 is 4, is 2, and now I add them together. And I get 384. That doesn't sound right. 84. Let's make sure I did my math right here. 24, 12, 13, 14. That part's right. 0, 1, and 4. Yeah. Okay. So this one's 384 feet squared. And if you do the math, that number is going to be 4 times larger than that number over there. 4 times. Okay. Now we're going to go ahead and do the perimeter. And again, perimeter this time is 24 and 24, which is 48, plus 16 and 16, which is 32. And when I add each of these together, I end up with 8 and 2 is 10, carry my 1. 4 plus 3 is 7, plus 1 is 8. That leaves me with 80 feet. And I want you to look at something here. Sorry, 80 feet. That number and that number, the 80 feet is 2 times the 40 foot. So when you double your length and you double your width, you will actually double the perimeter, but you will quadruple or make it 4 times the area. Let's continue. Last one. After swim practice, each of the, that should be fixed, so let's just fix that right now. T-H-E, there we go. Whoops, not R, T-H-E, there you go. Of the swim team members gets 8 ounces of juice. The coach brought 2 gallons of juice to practice. In your answer document, determine whether the coach brought enough juice for each team member. So as we go through and we're trying to work through this, I know that has something to do with the big G. And I know there's 4 quarts in a gallon, and there's 2 pints in each quart. And I know that in 1 pint there are 2 C's, and in 1 C there are 8 ounces. So I'm going to use this to help me solve this problem. So after swim practice, there were 30 team members. Each of them gets 8 ounces. 8 times 0 is 0. 8 times 3 is 24. So each of them are going to consume a total of 240 ounces. We need to determine if 2 gallons is enough. Well, if I have 2 gallons, I know there are 4 quarts in 1 gallon, and there are 2, 4, 6, 8 pints in 1 gallon. And inside each of those pints is 2 cups, and inside each of those cups is 8 ounces. So what I'm doing to myself is figuring out how many ounces there are in a pint, and that means that 2 cups are in a pint. Each of those cups has 8 ounces. That means that there will be a total of 16 ounces in a pint. And if I have 1, 2, 3, 4, 5, 6, 7, 8 pints, I multiply those two by 8. 16 times 8, 8 times 6 is 48. 8 times 1 is 8, plus 4 is 12. That means I have 128 ounces in 1 gallon. But now I have 2 gallons that I need. So I'm going to times that by 2. 2 times 8 is 16. Carry my 1. 2 times 2 is 4. Plus 1 is 5. 2 times 2 is, or 2 times 1, sorry, is 2. So I have a total of 256 ounces, not okays, ounces in 2 gallons. So I have a total of 256. I need to have 240. Yes, the coach does have enough juice to give each of his players 1 8-ounce cup. Well done. Alright, you guys, one last thing that is not in the review that I did not show you today, but I do want to kind of show it to you now. So we're going to spend a few minutes talking about this, and that is volume. Volume equals big B times little h, where big B is the area of the base of our object. So if I have, let's say a rectangular pyramid, or not a pyramid, a rectangular prism. Something like that. It probably would be a lot better, but mine's not perfect. But you get the idea. And I say that this length here might be 6 inches, this one might be 6 inches, and its height might be 2 inches. To calculate its volume, all I'm going to do is say volume equals the area of the base times the height. Well, the area of the base, which is big B, is going to be a 6 by 6. It's my length times my width. 6 times 6 times 2, because 2 is my height. And again, this is 6 inches, so I have 36 inches squared times 2 inches equals, and 36 times 2, 6 times 2 is 12. 2 times 3 is 6, plus 1 is 72 inches cubed. That's the key right here. It's got to be in cubic inches. And that is for volume for any three-dimensional object. Just calculate the area of the base, times it by your height. Alright, you guys, this was a bit of a long review, but hopefully you guys enjoy it. Don't forget to take your Google video or your Google form for the video review, as well as print out your review, which hopefully you've done already. Have your answers down, and you have it signed by your parent, and you can get 1 extra credit point. Also, just a reminder, tomorrow's extra credit in math on the test is going to involve PEMDAS. Please excuse my dear Aunt Sally, which is the order of operations. Have a great day.